In this video, I'll complete the slides that I have for the presentation. And in this case, we're going to talk about the hexadecimal or hex numbering system, base 16. And to begin with, again, we had octal, which were 3-digit words, which represented a byte. And that still was too much for people to remember, so the hexadecimal system became popular. And it's based on 16 digits, 0 through 9. As you see right here, let's see. 0. Oops, we got the wrong thing. Let's put it in a slideshow first. Okay. 0 through 9. And then once we got past 9, we had to have some special characters to represent the rest of the base 16. And we could have used anything. It didn't have to be the letters you see there. We could have used ampersand, hashtag, $sign, percent sign, things like that. But to make it simpler, they just chose the letters A, B, C, D, E, and F. So once we get past 9, we use A, B, C, D, E, and F. And this is known as base 16. 0 through F are the only symbols we use. There are no other symbols available for this. So an easy way to convert from decimal to hex is first convert from decimal to binary, and then instead of grouping the blocks in groups of 3 like we did for octal, we group them in blocks of 4. And then we convert them to hex using the following table. So if you look here, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go A, B, C, D, E, and F. And just like before, let's see if we have a slide for that. No, we don't. Let's go back here. If you notice, the first 10 digits are the same in hex as they are in base 10 or decimal. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I did not leave enough room, 14, 15. And this is base 10. So this is base 10. And base 16, the first, we have a 0 up here too. The first 10 are the same. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it becomes A, B, C, D, E, F. So again, the first 9, or first 10, starting with 0, are the same in base 10 or decimal as they are in base 16 or hexadecimal. It's only that 10 goes with an A, 11 goes to B, 12 goes to C, 13 goes to D, 14 goes to E, and 15 goes to F. So, if we look at 93, the first thing to do is put it into binary. So if we remember how to do that, remember this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7th. Well, 2 to the 0, 1. 2 to the first, 2. 2 squared, 4. 2 cubed, 8. 16. 2 to the 5th, 32. 2 to the 6th, 64. 2 to the 7th, 128. So if I look at this, this is 64 plus 16 plus 8 plus 4 plus 1. So if I add these up, 16 and 64 is 70, 80, plus 12 plus 13 equals 93. So, yeah, this is the binary equivalent of 93. So now we group them in groups of 4. So the first group is 0, 1, 0, 1. Well, if I go back 0101, and look at my little cheat sheet here, it's 5. Okay, so that's a 5 in hex. And then I have a 1101. Again, I go back, and 1101 is a D. So it's D, 1101. So 93 decimal is 5D hexadecimal. And so with 2 hex digits, I can represent all 8-bit binary words, or a byte. So let's try converting some of these. So we got 44 decimal. So let's first convert it to binary. So, knowing what I know, 2 to the 7th, which is 128, can't go in there. 2 to the 6th, 64, nope. 2 to the 5th, 32, yeah, I can. And so I got 44 minus 32 leaves me, what's that, 12. Okay, 16, can't go in there. 8, yeah, I can. So I have an 8, 4 left over. 4, yep, it can go in there. This is 0. And so the last 2 are 0. So I have 0, 0, 1, 0, 1, 1, 0, 0. Well, if I put 0, 0, 1, 0, that's 2. And 1, 1, 0, 0 is a C. So the answer is 2C. Let's check that. Yep, that's correct. Okay, and we'll erase this. Okay, so let's do the next one. 9. Well, that's easy. Remember, the first 10 digits, 0 through 9, are the same in decimal as they are in hex. So this is just going to be a 9. Yep, correct. Let's do one more. 111 in decimal. Okay, so we have 111 decimal. So, let's see. 2 to the 7th is 128, so that's too big. 2 to the 6th is 64, so that's good. So we have 111 minus 64. 4 from 11 is 7. 6 is 47. Okay, so we have 47 left. 32 is the next number. That's good. 15 left. 16 is no good. And the next one after that is 8. So 8 is good. And we have 7. And the next one after that is 4. Oops. Which is good. There we go. 4. We use here 3. Let's see. Did I put the 4 there? 8. Oh, there's the 4. And now we have a 2, which is a 1, and then a 1. So I got 0, 1, 1, 0, 1, 1, 1, 1. Well, I know 0, 1, 1, 0 is a 6, and 1, 1, 1, 1 is an F. So this will be 6F. There we go. So that's just kind of a quick way of how to do conversion to hexadecimal. And so that's our, just kind of summarize. We looked at all these 5 videos, converting numbers between decimal and binary, adding binary numbers, subtracting binary numbers using the 2's complement. We looked at ASCII code and Unicode, which is used to represent storage in computer in both numbers and letters. We converted to and from octal and decimal, and converted to and from hexadecimal and decimal. So, just one other, whoops, discard those, let's get out of there. Let's close this. One other thing I want to show is just basically, and I closed it up. Got it. So let's go to, where is it here? There we go. And put in my password. just wanted to go quickly to the courses. Go into here. And under course documents. If you look, there is another binary video. Somewhat of a simplistic video, but it shows a very good relationship between binary, octo, decimal, and hexadecimal. So really take a look at that. It's pretty good. And these are just a couple papers which summarize what I talked about. And then, of course, our binary view. For the assignment, let's go to assignments. There it is. We're going to be doing just that. Here's one where you want to add all these numbers together. And what you can do is you can print this out, do the numbers, or just write the numbers on write it on a piece of paper, and then, not piece of paper, but do it in like a word processing some kind, and just attach the whole thing. But let me know which ones you're doing so I know which ones answers you're doing it for. So we'll do binary and decimal conversions, hex conversions, octo conversions, and 2's complement. And if you notice, all these numbers are the same: 7, 12, 15, 8, 3, and 20. So converting to hex is the same as binary: 7, 12, 15, 8, 3, and 20. So it should help you a little bit. Then finally, just convert your name. Character just means, like for me, it would be B-O-B, capital B-O-B. Then put it in binary, in ASCII, hex, octo, and decimal. Again, post any questions on the discussion board, or send me a message, or just email me. Hope you understood this all. And that should do it for going over the slides. Thanks a lot.